A teacher is conducting a hypothesis test to determine if the average time with the student of class 10th place is significantly different from 4 hours a day. He conducted an experiment in which he collected the data for 64 class 10th students in a locality whose mean hours of playing is 3 hours. If the population standard deviation for the number of hours played by class 10th student per hour is 1.5, then with the 90% confidence level, the teacher will most likely reject the null hypothesis, as accept the null hypothesis, cannot reach any conclusion, and is not mentioned if the data is normally distributed. Now, since the sample size, that is 64, is greater than 30 and the population variance is known, hence we can apply the Z test irrespective of whether the distribution is normal or not. So in this case, my alternate hypothesis will be mu is equal, null hypothesis will be mu is equal to mu naught, where mu naught is equal to 4. Where mu naught is equal to 4, that is the 4 hours of playing, and my mu is equal to 3, which is the mean of the mean data of the observations obtained from the sample population. And my alternate hypothesis will be equal to mu not equal to mu naught. So it will be a two-tailed test. And hence, when we calculate the Z value is equal to mu minus mu naught, that is equal to 3 minus 4 divided by the population standard deviation, and this divided by the square root of the number of observations, that is 64. So it is actually equal to mu minus mu naught divided by sigma by square root of n. So it will be equal to minus 5.33. Now for the 90% confidence level, since it is a two-tailed test, so the critical value of alpha, that is Z alpha by 2, will be equal to plus minus 1.645. And since the Z value lies beyond this Z critical value, that is somewhere over here, hence the null hypothesis is rejected. So we reject the null hypothesis. So option A is the correct option.